find the solution of the given initial value problem. So we have a second order constant coefficient linear differential equation, and when we solve we get two solutions, and the general solution will be C1 times the first solution plus C2 times second solution, and there will be two unknown constants, and we determine those values using these initial conditions. Okay, there are two initial conditions, and to solve this we first find the characteristic equation. So characteristic equation is 9r squared minus 12r plus 4 equals 0. We solve this for r. Looks like it factors 4 times 9, 36, 6, 6, 12. So this is 3r minus 2 times 3r minus 2, or 3r minus 2 quantity square equals 0. That means r equals 2/3 twice, or 2/3, just 2/3 with multiplicity 2. Okay, repeated roots, and we know that, look at the right hand side here, when the roots are equal, repeated roots, and we just say r, then e raised to rt times t times e raised to rt are two solutions, and we can write down the general solution now. Then the general solution is y equals C1 arbitrary constants e raised to r 2/3 t plus C2 times t e raised to 2/3 t. Okay, that's the second solution. And now we need to determine C1 and C2 using these initial conditions. Look at the second initial condition. That requires y prime. So we need to find derivative of this function. So let's find the derivative. Y prime t. By the way, the final solution will be given by this here. But to use the second initial condition, we need to find the derivative. Okay. So let's find the derivative. Exponential function itself, and 2/3 comes to the front. 2/3 C1 e raised to 2/3 t plus, we got a product of two functions, so we must use product rule. So that's C2 times derivative of first factor times second, okay, plus leave first alone, take the derivative of second, which is 2/3, I'm going to write in the front, e raised to 2/3 t. Okay. Next, let me simplify this second, this little bit, but we don't have to. Okay, let's leave here. Using the first initial condition, y at 0 equals 2. Using y at 0 equals 2, so y value, so we're gonna use here now, y is 2 when t is 0. So this y is 2 when t is 0. E raised to 0 is 1, so C1 plus t is 0. Okay, so the whole thing is 0. That means C1 equals 2. Okay, and from this second initial condition and this y prime, we can find second solution. Okay, let's use the second initial condition here. Y prime 0 equals -1. So using y prime at 0 equals -1. So y prime is -1 when t is 0. So 2/3 C1 e raised to 0, which is 1. So 2/3 C1, 2/3 times C1, and C1 is 2, plus C2 times, C2 is to be determined, 1 times e raised to 0, which is 1, so it's 1, plus 2/3 times t is 0, so everything is 0, Okay, so -1 equals 2/3 times 2 4/3 plus 1 C2. Now subtract 4/3 from both sides, you get C2 equals -1 minus 4/3. -1 minus 4/3, that's -3, -7/3. Okay, now we're gonna plug these values back here. Okay, C1 equals 2, C2 equals -3, okay, just here, and we get the final answer. So thus the solution y is C1, that's 2 e raised to 2/3 t, plus C2 is -7/3, so this is negative, minus 7/3 t e raised to 2/3 t. Final